I am again with you with my new video lecture, and in this video lecture we will study nth order derivatives. So far till 10 plus 2 we have studied the differentiation up to second order, maximum third order, fourth order, something like that. But if we are asked to differentiate 1000 times, 2000 times the given function, so it would really become very cumbersome for us to differentiate it 1000 times, 2000 times, or something like that. So for our help, the nth order derivatives of some simple functions will come for the rescue. Let us firstly take a function y is equal to x raised to the power m. In this we have to differentiate it n times. So we will not rush for the things, we will wait and do the differentiation step by step, and then we'll see that what happens. For its first order derivative will be x raised to the power m minus 1, and its if I say second order derivative, it will be m minus 1 x raised to the power m minus 2. Fine. And if I say what will be its third order derivative, you will write it as, you will say, sir, simply it will be m minus 1, it will be m minus 2, and it will be m minus 3. So continuing likewise we will get, if we see the pattern, so pattern over here is that here is 3, here is 3, here is 2, here is 2. So when we will continue something like that and go up to nth order, so it will be x raised to the power m minus n. And here you see it is running, here it is 3, and it is running 1 less than 3. 1 less than 3 is 2, up to 2, it is running up to 2. Whenever it will be n, it will be running up to minus n minus 1. So for nth it will be m minus 1, m minus 2, and so on. It will be m minus n minus 1 and the braces. And here will be, here is 3, here is 3, so it will be x raised to the power m minus n. So this will be nth order derivative of x raised to the power m. Similarly, we can also find nth order derivative of some other simple function. So let me write as another simple function and say this function is, it will be, say it is y is equal to 1 by ax plus b. And what happens if we are asked to find its nth order derivative? It will be y1, we will firstly find the, we will proceed step by step. First order derivative will be, it can be written as ax plus b raised to the power minus 1. So its first order derivative will be minus 1, it will be ax plus b, and it will be minus 2 and into a. So this will be, if I write it as, it will be minus 1, it will be a divided by ax plus b raised to the power 2. Fine. Similarly, if I find second order derivative, so it will be minus 1. Now I am writing it directly. It will be minus 2, because when it will go up over here, it will be minus sign. So it will be minus 2, and divided by, it will be ax plus b raised to the power 3 into a square. Fine. Similarly, third order derivative will be minus 1 minus 2 minus 3 divided by ax plus b raised to the power 4 into a cube. Now we will try to generalize something, and before generalizing, can I collect these two minus signs and write it as minus 1 raised to the power 2, and 1 into 2 is 2 factorial into a square divided by ax plus b, it is cube. Fine. And may I write it something like minus 1 raised to the power 3, and it will be 1 2 3. 1 into 2 into 3 is 3 factorial divided by ax plus b raised to the power 4 into a 3. Now we will try to find the generalization, and we will try to generalize this one. So what we'll get, we will see. If we see, here is 3 a raised to the power 3, here is 2 a raised to the power 2, here is 1 a raised to the power, it is 1. So whenever it will be n, so I have no hesitation in writing that here it will be a raised to the power n. Fine. Whenever here is 3, here is 3 factorial. Whenever here is 2, here is 2 factorial. So whenever here it will be n, so here will be n factorial. And whenever here is 3, here is 1 minus 1 raised to the power 3, here is 2, here is minus 1 raised to the power 2. So when we write that it will be, for nth, it will be minus 1 raised to the power n divided by, and here in the denominator it's 1 power more. So whenever it will be n, so it will be 1 more n plus 1. So this is nothing but nth order derivative of y is equal to 1 by ax plus b. So it is very simple. What we have to do, we have to differentiate step by step, and have to move up to third order, or at max up to fourth order, and after that we shall try to find the elements of generalization between them. And once we are able to find, like in both these we have done, we have found the elements of generalization, and once we are able to find the elements of generalization, then we can simply write the nth order and derivative. So one more function, simple function, we will study and try to find its nth order derivative, and that function is y is equal to log ax plus b. So can you help me to find its first order derivative? It is y1 is equal to 1 by ax plus b. In case of log, you simply know it will be something like that, and here will be a. What will be its second order derivative? It will be simply minus 1 divided by ax plus b whole square into a square. What will be its third order derivative? It will be minus 1, it will be minus 2 divided by ax plus b raised to the power 3 into a cube. So now can I write it something like that? It is minus 1 raised to the power 1 into a square divided by it is ax plus b whole square. So can I write it as minus 1 raised to the power 2 into 1 into 2 is 2 factorial, find into a3 divided by ax plus b raised to the power 3. Now we'll try to see the elements of generalization in these derivatives. When here is 2, you will see here is 2. So whenever we'll talk about the nth order derivative, we will see that whenever here will be y n, it will be equal to, so here is 2, here is 2, so it will be a raised to the power n, and here is 2, here is 2, so it is divided by, it will be divided by ax plus b raised to the power, it will be same n, because here is 3, here is 3, so it will be same. So whenever we see here is 3, here is 1 less, so it will be minus 1 raised to the power n minus 1, into whenever here is 3, here is 1 less, so it will be n minus 1 factorial. So this is the nth order derivative of the function, that is y is equal to log ax plus b. So this is, you see, this is very simple. So before that we wind up today's lecture, I would like to just do one more generalization based upon this question. In this question, if it is given that we have to differentiate x raised to the power n times, if it is given that it is y is equal to x raised to the power n, and we are asked to differentiate it n times successively. So how will do? Let us see. First will be n x raised to the power n minus 1. Second will be n minus 1 x raised to the power n minus 2, and third will be n minus 1 n minus 2 x raised to the power n minus 3. As I have already told you, now I will try to see the elements of generalization. It will continue something like that, and whenever it will be yn, what will get? See here, if I say here is 3, here is 3, here is n minus 3. So whenever here will be n, so here will be n minus n, x raised to the power n minus n. So here is 3, and it is running up to 1 less than 3. 1 less than 3 means it is running up to 2 only. So this will be n, whenever it will be n, so this will be n minus 2, and so on n minus 1, and it will be x n minus n, because here is 3 and here is n minus 3. So whenever here will be n, it will be n minus n. So I have written n minus n, and we know that n minus n will be x raised to the power 0, and x raised to the power 0 is 1. So this is nothing but equal to n minus 1, n minus 2, up to if we see it will be 1. So it is continuously decreasing by 1. So if here is 1, so one term preceding 1 will be 2, so it will be 2. So if we write it in the reverse order, it will be 1 dot 2 dot 3 up to n. So can I write it as n factorial? So therefore there is no exaggeration in saying that derivative of this y is equal to x raised to the power n, nth order derivative, is equal to n factorial. So this is very important result, that whenever we are given a polynomial like x raised to the power, it is 10, and we are asked to find y10, so it will directly be equal to 10 factorial. Similarly, if we are asked to find 1y 1000 times, so it will be 1000 factorial. It is very easy, isn't it? So that is what we have studied in today's lecture, that what is nth order derivative and how we are able to find nth order derivative of very simple functions, like we have studied this one x raised to the power m, we have studied this one log ax plus b, we have studied 1 by ax plus b, and then we have studied the deduction based upon the first example, the first polynomial we have taken. So this deduction we have done. So I hope that you all will be able to understand the concept that I have discussed today. So with that, I would expect you to just do some more exercises upon these questions, based upon these questions. So that is all I have from this lecture, and very soon I will be with you with my next video lecture, and on the same topic, nth order derivative, we will take it further to the new dimension. So till then, take care, bye bye, stay at home, stay safe.